Hi, in this video, I'm going to work through some problems dealing with complex numbers and how you do various operations with complex numbers. All right, so if you want to read about it, this is in section 1.4 of the textbook. Okay. All right, complex numbers is a number system that is like encompasses the real numbers, but throws in some extra types of numbers that we need if we want to kind of finish the story when solving a quadratic equation. You know how sometimes you get like a negative number under a radical, under a square root, and so you get a number that is not a real number. So it doesn't fit within the real number system. You know, the real number system is suffices for just about everything you do in algebra and even in calculus. Except occasionally we need to expand to the complex number system. You know, so your rational numbers are all your really nice numbers, like your whole numbers, like 0 and 3, your fractions like a half, or even negative 2 and 3/4, even your decimals like 0.75. And even decimals that repeat, like 0.333 repeating, okay? Your irrational numbers are numbers like pi, okay? They're decimals where you might have a pattern, okay? Or not, like sometimes it's a decimal that just keeps on going forever and there's no real obvious pattern to it, and the decimal just keeps on going, doesn't terminate, doesn't repeat. Those are irrational. Right? In the context of what we're doing, quadratic equations, rational numbers happen when you have something like square root of 36, which simplifies to be a nice number. Irrational numbers happen when you have something like square root of 7, which you can't simplify so that it doesn't have a radical. And the square root of 7 turns out to be a decimal that would just keep on going forever. All right, now the new thing we're talking about happens when you have like square root of a negative number, like negative 49 or something like that. If you're doing the square root of negative 49, that square root of negative 1 right here becomes or is replaced with the letter I. Okay, I equals the square root of negative 1. And then you just simplify the radical part like you normally would. So that would be 7. And then you would say square root of negative 49 is 7i. Okay. So imaginary numbers happen when you have a negative under the radical. And sometimes they look just like that, 7i, but sometimes they wind up looking like things like negative 2 plus 3i, you know, where you have a real part and an imaginary part. Okay. All right, so I wanted to tell you about that. Complex numbers really are any number that can be put in the form a plus bi, where a and b are real numbers, okay, and I equals the square root of a negative 1. Somebody just made up I to stand in place of the square root of negative 1, okay? So one of the things you're going to be asked to do is you're going to be asked to simplify something that turns out to be imaginary. So that negative under the radical is what causes that to happen. So you kind of separate out the negative from the rest. And then you work on the square root of 48 like you're used to doing. Okay? A lot of us just break it down until we have it completely factored. We have the prime factorization. Okay? Let me do that again. I kind of got out of order, got ahead of myself. Okay? All right, and you wind up with 4 2s and a 3, okay? So if you were going to do the square root of 48, those 4 2s make a perfect square. Those 4 2s would be 16. Some people prefer looking for pairs, and they say, I'm going to bring a 2 outside. Here's another pair. That's a perfect square. That's 4. So the square root of 4 is 2. And then underneath the radical, I'm going to leave 3 underneath it. Okay? All right, so the square root of 48 turns out to be 4 square root of 3. So you come back up here and you think, well, this is 4 square root of 3. This is I. And then what's customary is that you put the I between the two. And that would be how you would simplify the square root of negative 48. Okay. All right, another thing you'll be asked to do is to add and subtract imaginary numbers. Now, when you're doing this can be thought of just like combining like terms. But when you're doing this, make sure that you're writing one step in there, the step where you're removing the parentheses. See how that second set of parentheses has a minus in front? Don't forget that's like having an invisible 1. So you'll want to distribute that. Where on the other one, it's like an understood positive 1 out in front. So the first imaginary number, when I go to remove the parentheses, nothing really changes. But on the second one, since I'm subtracting, that's going to become plus 7 and plus 2i. Now, I'm kind of working this, thinking about the I just like I would if it were an x. And so I'm able to, combine my like terms. And I would wind up having a positive 4 and a positive 7i. And then 4 and 7i, those are not like terms. So you can't put it together and say 11i. Okay? You would stop right there. So with adding and subtracting, you pretty much think of it just like combining like terms way back when. All right, now we're going to do a chunk of multiplying problems. Now there's something that happens on your multiplying problems that you have to be careful about, or that you have to realize. All right, you already know that I equals the square root of negative 1. What's going to happen on a lot of these is when you wind up distributing, you'll be doing an I times an I. So you'll get an I squared. So if I square the left side, I would square the right side. Can you kind of see why we want to say that I squared is equal to negative 1? You can kind of see why we would want to make that happen. If I squared the left side and squared the right side, you can kind of see you might want to think of it as just I squared equaling negative 1, thinking of the 2 undoing the square root, okay? All right, so that's the important thing. It's going to happen a lot, so don't forget. Anytime you see I squared, I is not a variable, okay? So you can replace I squared with negative 1. So we're going to do 5i times 3, would be 15i. Then we're going to do 5i, and we're going to multiply by the 2i. And notice it's a positive 5 and a negative 2i, so that's going to make it minus overall. So that would be minus 10, and that would be I squared. So do that step. Don't get ahead of yourself. Okay. Then think this I squared is going to be replaced with a negative 1, and that would be 10 times that. Okay, so then you come in and you think, well, that's 15i, negative 10 times negative 1 would be positive 10. And then it's customary to write it in a plus bi form. You normally write it in that order. And that would be your final answer on that one. All right, number 4 is a little bit of a pain because of the radicals have not been simplified yet. And so on one like this, I'm going to go ahead and do this one. You got to be careful about something. If you have to take, let's just do this part. If you have to take square root of negative 8 times square root of negative 3, it is not going to be the square root of positive 24. You can't just put these back together underneath and do that and then simplify that. It would be 2 square root of 6. That's not what it's going to turn out to be. What you have to do when you're multiplying radicals that have negatives underneath is you have to pull out the I first. So if you were doing those two, you would want to realize that this is the same as I squared root of 8. This is the same as I squared root of 3. So you really have I times square root of 8 times square root of 3. And so you wind up with an I squared and a square root of 24. See, normally you can put things back together under the radical when you're multiplying, but it's just when there's negatives, you got to be sure you've pulled out the I first. So I squared is a negative 1. And so you'd wind up having negative 1, and then square root of 24 would be 2 square root of 6. So that's negative 2 square root of 6, not positive 2 square root of 6. Do you see that? Okay. So let's go ahead then and work through this problem from the start. So what I would do first is I would take out the I from these. Wouldn't necessarily simplify the whole radical. You could, though, if you wanted to. All right, the 7 doesn't have an I because the minus is in front of the radical, not underneath. Okay, now we would want to distribute. Okay, so let's go ahead and see what that's going to do. When you're multiplying radicals, the outsides get multiplied and the insides get multiplied. Okay, so if something's outside in front of the radical, you can multiply it because that's just I times square root of 8, I times square root of 3, all multiplied together. Then we do I square root of 8 minus square root of 7. That's going to be I square root of 56. Those are both inside, so they can be multiplied underneath. All right, when we get to here, we have a couple things to do. We have to simplify the radicals, and this I squared, we're going to put a -1 in place of it. So here's where you would work on simplifying the radical. So 24 is 4 times 6. Some people would stop there. I like to stop there because 4 is a perfect square. Others like to go all the way until they get it completely factored, and then they notice the pair. And so a 2 would be outside and a 6 would be underneath. So this would be 2 square root of 6. All right. Then we'll do the same thing with the 56. Okay. So let's go ahead and work on the 56. I'm going to go ahead and erase this right here so I have room to do the 56. Do a bigger erase. Okay, so let's work on the 56 now. So when we do the square root of 56, it's like 8 times 7. It's like 3 2s and a 7. So there's a pair of 2s. So 1 2 can come out, but then 14 is trapped underneath. So this would be an I and then a 2 square root of 14. Now, when you see how it all works, you can take a shortcut or two, but not from the beginning to the end. So this would just be -2 square root of 6. This would still be minus, and then you typically write it 2I square root of 14. And that would be, that would be right there, what you would type in. Okay. All right, and then these two aren't too bad. These, though, are binomial times a binomial. So some of you learned to do that using something called FOIL. And so you did, -4 to both, and then you did the -3i to both. So -4 times -2, -4 times +5i, -3i times -2, and then -3i times +5i. Okay. Now, at this point, you're going to want to replace the I squared with a -1, and you're going to want to combine your like terms. So we get -14i, and then -15. This is times a -1, so that makes it +15. Then you have another set of like terms that need to be combined. So your final answer would be 23 minus 14i. And of course, those aren't like terms, so you wouldn't combine them. Okay. Now, the problem number 6 is similar to number 5, but watch what happens on this one. When we distribute the 3 and then go in and distribute the -2i throughout, we get 4 terms like we did on the other one. We get a 9 plus 6i minus 6i minus 4i squared. Okay. But notice on this one, the middle term turned out to be the same thing, just opposite in sign. So they canceled out, and the I squared we replaced with a -1 like we did on the other. But we wind up then just having 9. This canceled out, and then that would be +4, and we get the real number 13. We started with i's in the problem, and we wound up just with the number 13 as the final answer. We're going to make use of this result in just a minute. See, that was very different from what happened on 5, okay? And so the deal was, the reason that happened is, see how that's exactly the same? The 3's and the 2 i's in the same location. The only difference is we had a negative on one of them and a positive on the other. And that's what eliminated the I entirely, okay? we're going to make use of that on number 7. Okay, 7 and 8. On these, we're looking at dividing by an imaginary number, but sometimes the directions for this will say to rationalize the denominators. Okay. You may remember doing that if you took Math 100. That was something we did in Chapter 10. It's not considered simplified if you still have radicals in the denominator and you don't see the radical, but the I really is a square root. It's really square root of -1. So here's the idea. What we're going to do is we're going to multiply by I on number 7 down on the bottom. But if we do that, to make it mathematically okay, we're going to multiply on top by an I. Okay, so that means we'll have 5I on top, and on the bottom we'll have a 2I squared. Okay. All right, so now the I squared gets replaced with a -1. And remember, that's being multiplied by the 2. So we wind up having 5I on top and a -2 on the bottom. And that's the same as a -5I over 2 or -5I all on top over 2. The negative out in front or on top are usually the ways you write your final answer. One negative somewhere. Okay. All right, so that would be number 7. All right, now, issue with number 8 is just multiplying by I is not going to help you. It's going to just move. You'll get rid of the imaginary on the end, but you'll move an I over here with the 4. So we're going to use what we found happened in number 6. We're going to multiply not by one thing, but 2 things. We're going to make sure we put a 4 and an I, but since the original one had a minus, we're going to use a plus. And then if we multiply on the bottom by something, we'll need to multiply on top so that we're not really changing the problem. You see how these are really equal to 1, so they're not really changing the problem, okay? All right, now watch what happens. When we do -3 times 4 plus I, we get -12 minus 3I. When we multiply the bottom, 4 minus I, 4 plus I, we get 4 terms to start with. 16 plus 4I minus 4I minus I squared. So like we were hoping, the middle terms cancel out, and the I squared is going to get replaced with a -1. So you wind up with -12 minus 3I, and then in the denominator you have 16, and that was minus a -1. That's really plus 1. So your answer to this is -12 minus 3I over 17. All right, now sometimes they make a big deal about writing it in complex number form. So sometimes you'll be asked to be sure to do that. What they mean is to separate it so you have the A and the BI part. Okay. All right, I don't care that much about that, but in case my math lab is really emphasizing wanting it in A plus BI. So for this one, either that or you may be needing to separate it into the 2 pieces. Okay. All right, so we're almost through with complex numbers. Let me just do a little exploration before we do powers of complex numbers. You need to kind of get the idea that there's really only 4 possibilities for what I raised to a power can be. Okay, so I, we know, is the square root of -1. Okay, but I squared, and I squared we know, that's -1. But I to the third, what we can think of there is I to the third is an I squared and an I. You know how I to the third is really 3 I's multiplied together. So we know I squared is -1 and still have an extra I left. So see how I to the third really simplifies to be -I? All right, and then I to the fourth, we can do the same thing or something similar, but I might use I squared. Wouldn't I to the fourth be 4 I's multiplied together? And we could do like I squared times I squared. So I squared is -1, can replace those with -1, and I wind up with +1 for an answer. So you really get the I is just I. I squared simplifies to be -1. I to the third simplifies to be -I, and I to the fourth simplifies to be 1. Now watch what happens when you do like I to the fifth. And let me see if I can put another space in here. Okay. If I do I to the fifth, isn't that I to the fourth with an extra I? Well, so that would be 1 times I, which is I. All right, so that would be the same as I. And if I did I to the sixth, that'd be I to the fourth with 2 i's left. I to the fourth is 1. I to the second is -1, so I'd get -1. You see how it's the same as I to the second? Okay. Well, the same thing happens. I to the seventh would be equal to this one. So I to the seventh would be the same as I to the third. I to the eighth would be the same as I to the fourth. Okay. You wind up having this idea that, you know, if the number's small enough, you could actually just keep counting until you figure out where you would fall. So for I to the 23rd, I could say that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and keep counting. But it's kind of a big number, so you want a strategy for that that's going to help you. Okay, so I want you to see just one more. So I to the seventh would be I to the fourth with 3 i's left. So it's going to be the same as I to the third, isn't it? Because that's 1. And I to the third turns out to be -I. And I to the eighth is I to the fourth, which is 1 times 1, which is back to 1. Okay, just see how that happens? All right, so the question I have for you, or the thing I want you to realize, is that you're going to wind up being at getting 1 if you had an I to the fourth, or an I to the eighth, or an I to the 12th, or an I to the 16th. You know, see, those are multiples. The exponents are multiples of 4. That means you would have gotten here at I to the fourth, and then 5, 6, 7, 8, and then 9, 10, 11, 12. So that observation is the thing I use more than anything else. Because all the ones that have an exponent that's a multiple of 4 are going to wind up really equaling 1. So what I'm going to do when I have I to the 23rd is I'm going to think about, I to the 23rd. It's really just a whole bunch of i's. And what I'm going to do is I'm going to think, well, it's really I to the 20th with 3 leftovers. And I to the 20th is a multiple of 4, so that'll equal 1. And so then I just have that left. And if I don't readily know what I to the third equals, I'll just figure it out myself. So I would separate it into I squared times I. And so that would be 1 times -1 times I. Okay, so that should be -I. So what you can do is you can look at 66 and you can try to think about what's a multiple of 4 that's close to 66. And so you can kind of run through your multiples of 4, or you can divide 4. I sometimes do this, divide 4 into 66. It doesn't go in there evenly, goes in there 16 times. And see, that 64 is a multiple of 4. And see the 2 left? So I to the 66th is I to the 64th with 2 left. Okay, and I to the 64 is a multiple of 4. So that means it's going to equal 1. And I know I squared is equal to -1. So overall, that should equal -1. Overall, this one's going to equal -I. Okay. All right, and that's kind of how I do it, is I look for a multiple of 4 that's close to that number, and then I use that to figure out what the value would be. All right, and a fun one might be something like this too. Sometimes I do this. Say I had I to the 33. Okay. No, let me change that to a 31, might be funner. All right, say I had I to the 31. I might think this. I might think, well, I to the 32 would equal 1 because 32 is a multiple of 4. So I might think this. I might think, okay, I've got these 4 possibilities, right? I have I, -1, -I, and 1. I to the 32 would be here. Okay, so I to the 31 would be back 1 and would equal -I. Okay. All right, so just be working a little bit on the homework for complex numbers, trying to make sense of it. And then if you have any questions, we can take care of that during the question and answer session. Okay. So let me stop.